Alright, welcome. In this video, we're going to be sketching some graphs of some quadratic equations. We're going to be working through Algebra 2 homework 4.1. So the first 6 problems is like find the vertex and sketch the graph. Okay, and remember that the formula that we need for a vertex is x equals negative b over 2a, and then we'll plug in to find the y coordinate. So for number 1, I'm going to need more room. Maybe you write small and I left enough room for you here. But if you write big, if you're like me, you need to use a separate sheet of paper, right? No sense in cramming our work in. We've got plenty of paper. If you need more, you need to just ask me for some because I've got plenty too. All right, f of x equals negative 6x squared. Okay. This is negative 6x squared plus 0x plus 0, right? So a is negative 6, b is 0, and c is 0. So the x-coordinate of the vertex is negative b over 2a. That's going to be 0. And then y is going to be what happens when I plug in x equals 0 over here. So it would be f of 0, which is negative 6 times 0 plus 0 plus 0. And that's just going to be 0. Okay. So I've got my vertex over here at the origin. And, you know, I think I'm going to just think about it in terms of that leading coefficient here, this negative 6 on the x squared. I know that the negative means it's going to open down, and the negative 6 means it's going to be very narrow. So I'm going to just try to draw what is, in my mind, a very narrow parabola, and then that's the origin, so I can kind of just, you know, put this in like that. And that's a good sketch. All right, number 2. Y equals, already with the mosquitoes, it's way too early for that. Oh boy, okay. Y equals negative 2x squared minus 16x minus 32, all right. Minus 16x. Right. So to get the vertex, we're going to say, okay, a is negative 2, b is negative 16, c is negative 32. If I was going to try to find the x-intercepts of this thing, this would be something I would want to factor out a negative 2 from. But that's not what we're doing here. We're just finding the vertex and sketching the graph, so we should be good. All right. Then negative b will be negative of negative 16. Divided by 2a would be 2 times negative 2. So I've got 16 over negative 4 is negative 4. And then the y-coordinate is going to be what I get when I plug in negative 4 for x. So that's negative 2 times, if I square negative 4, I'll get positive 16. Minus 16 times negative 4 minus 32. Okay, this feels like possibly, yeah, okay, that's going to be negative 32 minus 32 is negative 64. Plus 64 is going to be 0. Okay, so negative 4 and 0 is the coordinates of my vertex. And maybe this time I'll label that since it's not at the origin. So that's the point, negative 4, 0. And then it's going to open down because of the negative 2x squared. And it's going to be pretty narrow because of the because of it being 2, you know. So I draw what is, in my mind, a pretty narrow looking parabola. And negative 4 is 0. Well, y equals 0, that's on the x-axis, so I might just draw in a little x-axis like that. And I don't know, maybe we're looking pretty zoomed in on it. That's gonna be a pretty good sketch there. All right. Number 3. H of x equals 2/3 x to the 2 plus 4x plus 6. In this case, a is 2/3, b is 4, and c is 6. So the x-coordinate of the vertex is going to be negative b over 2a would be 2 times 2/3 is going to be 4/3. Okay, now if I take 4 and I divide by 4/3, it's like multiplying by 3/4. Okay, so I'm going to say that's negative 4 times 3/4 is going to be negative 3. Okay, and then the y-coordinate is going to be what happens when I plug in negative 3 into this function. So h of negative 3 equals 2/3. If I'm going to square negative 3, and I'll get 9. Plus 4 times negative 3 plus 6. Okay, so, oh, interesting. Yeah, see how this is going to be another perfect square. Oh, I just can't get that mosquito. Okay, so yeah, this one's going to come back 0 as well, because 2/3 of 9 is 6. 6 plus 6 is 12. 12 minus 12 is going to be 0. Okay, so -3, 0. Plot that point over here. And then it's going to open up because of the positive number of x squareds. And it's going to be a little wider because of 2/3. Wider than the standard y equals x squared parabola. So maybe I'll try like that. Yeah, that's pretty okay. Give it an x-axis, give it a y-axis. That'll be a good sketch. All right. Number 4. Y equals 2x squared plus 16x plus 29. And we are going to find the vertex. X equals -b over 2a. -16 divided by 4 would be -4. And then the y coordinate will be, I'm going to plug in -4 for x. So 2 times, if I square -4, I'll get positive 16. 16 times -4 is -64. All right, so I've got 32 minus 64 would be -32. -32 plus 29, -2. Okay, so -4, -2. All right, and then we will, what am I thinking here? Oh, it's going to open up and be pretty narrow because of it being 2x squared. Because of the positive 2, narrow because of the fact that 2 is bigger than 1. So if it's -4 and -2, well, then this is below the x-axis because y is negative, and it's over here to the left of the y-axis, so maybe I'll just draw it like that. Okay. The y-intercept is going to be 29, so we don't need to be able to see that on our graph. Maybe it'll be like that. Probably not drawn to scale. That's okay. It's just a sketch. All right, for number 5, g of x, -9x squared plus 12x minus 4. Okay. Get the coordinates of the vertex. X equals -b over 2a, so -b over 2a. It's going to be -12 over -18. Okay, and that's going to be 2/3 if I divided both of those by 6. All right, then y is going to be g of 2/3. And then that'll be -9. If I square 2/3, I'll get 4/9. Okay, that's helpful. Plus 12x, so 12 times 2/3 minus 4. Now I'm going to say, all right, I could say that's -4 plus 8 minus 4, and that's 0. Interesting. Okay, yeah, I could see how that. If you're real Algebra 1 expert, you could see maybe this is a perfect square trinomial. It must be, but that's not what we're talking about here. Okay, x is 2/3, y is 0. Okay, so I'm going to put that point here. X is 2/3, y is 0. Okay, now put the little coordinates above the bow that this parabola is going to open down because of the -9x squared. Now the -9x squared, that's going to cause this parabola to be very, very narrow. So I'm going to try my best to draw like a very, very narrow parabola. Okay, so that's 2/3 and 0. 2/3 happens over here to the right of the y-axis, and then I'm going to have a hard time doing this without a straight edge, but I thought I had one of those over here. Just draw it like this. But if you don't have a straight edge and you just want to not draw a y-axis, that would be completely fine too, right? absolutely have to have the axes. I'm going to provide the axes for you in the problem, right? I just want you to sketch what you think it looks like. Number 6. So last of these. Y equals negative 3x squared plus 6x minus 5. All right, cool. This is going to be a good one. X equals negative b over 2a. Okay, negative 6 over negative 6 is 1. Okay, y is going to be what happens when I plug in 1 for x, so negative 3 plus 6 minus 5, because 1 squared and 1, they don't really do anything to the negative 3 and the 6. So I'll be over here, I'll say 6 minus 5 is 1, 1 minus 3 is negative 2. And so now I can plot my vertex, x equals 1, y equals negative 2. So it's there. Okay, so that will be where x is positive and y is negative. That will be in the 4th quadrant. So maybe this time I'll kind of sketch the axes first. It would need to go, it's going to be closer to the y-axis than the x-axis. Yeah, because y is negative 2, so I'm going to draw the x-axis about right here. And then, okay, it's going to open downwards, and it's going to be pretty narrow because of the negative 3. Okay. Down because of negative, narrow because of 3. So let's say it's going to be like that. That's a pretty good parabola there. All right, so that's 0.1 and negative 2. Or we could have labeled that by, labeling that as 1 and this is negative 2. That would have also kind of given the same information. Okay, that's enough of those. That was a lot. Okay, now we're going to write the function as y equals ax squared plus bx plus c, and we're going to give the y-intercept of the graph, but we're not going to need to sketch. So this is where we're going to practice our FOIL a little bit. Okay, and if you need more practice on this, let me know. I've got extra worksheets I'm holding on to. I'm not even really publishing them. But if you need more practice on this, please contact me. Okay, so for number 7, x plus 2, x plus 7. Okay, with these, with binomials, you might be able to do these in your head, and that's fine. If you can, do that. If you're having any sort of errors with these, what you want to do is, I think, use the box method. Because we'll use the box method when we go to multiply like larger items, like that have 3 or 4 in them by each other. And the box method, I think, is really the way to go. So we're going to write out x and then plus 2 against x and plus 7. And then we multiply x times x, and we get x squared. Multiply x by 2, and I get positive 2x. Multiply 7 by x, and I get positive 7x. And 7 times 2 is positive 14. Okay, so I can take my x squareds here. My x is there, plus 9x, plus 14. Okay, the y-intercept is going to be, well, what happens when x is 0, okay, which is just going to be 14. Okay, so number 8, y equals x minus 9 squared. Okay, this is not just going to be x squared minus 9 squared or x squared plus 81, nothing like that. Okay, I'm going to set it up the exact same way we did the other one. X and a minus 9 against an x and a minus 9. Okay, I'll multiply x by x, I'm going to get x squared, negative 9x, another negative 9x, and negative 9 times negative 9 is positive 81. Okay, so I'm going to have x squared, negative 18x, positive 81. Okay, so that y-intercept is going to be x equals 0, and when I plug in x equals 0, I'm going to get y equals 81. So x equaling 2x plus 1 times x minus 4. So this has got a little something different. It's got a 2x there. So we'll have a 2x and a plus 1. We're going to multiply that against the x and the minus 4. right? So x times 2x would be 2 times x is going to be 2 times x squared. X times positive 1 is positive 1x. Negative 4 times 2x would be negative 8x. And negative 4 times positive 1 would be negative 4. Okay, so I'm going to rewrite f of x, ax squared plus bx plus c, so 2x squared. Negative 8x plus x is going to be negative 7x minus 4. And so I asked about the y-intercept. So I'm going to say the y-intercept is where x equals 0, and when x equals 0, y is going to be 0, 0, negative 4. I bet I can fit one more here. Number 10. G of x equals x minus 1 times 5 minus x. Okay, I'm glad I put one of these on here too. Right, so this will give us like a negative leading coefficient. This will be a parabola that opens down. Okay, I'm going to say x minus 1 against 5 minus x, 5x. Okay, negative 5. And x times negative x, that would be negative x squared. And then x times negative 1 would be plus x. All right, and now I'm going to have a negative x squared Okay, and so you don't have, so all the way back up here, you know, I was able to have them kind of like nicely on diagonals. That's only if you have like descending powers of x, you know, where the first power over here, no power over here, because I had the number first and then x after. That kind of ruined that, but that's not a big deal. There's only 4 things to look at here. So I know that my number of x's are going to come from here. 5x and 1x is going to be plus 6x. And let's see, where is it? Negative 5. So the y-intercept, that will be x equals 0, and y is going to equal g of 0, which would be negative 5. All right, moving on to the back. Now we're going to find the x-intercepts and sketch the graph. This is where we're going to need to do some factoring, I guess, except for on this, really like being on the lookout for a greatest common factor. All right, so 11 y equals negative 2 times x plus 1 times x minus 4. Okay, so if I'm trying to find the x-intercepts, that's where y equals 0. Okay, well, that'll be 0 equaling negative 2 times x plus 1 times x minus 4. We're going to apply the zero product property. If these 3 things multiply together to equal 0, one of them has to be equal to 0. So it's either the case that negative 2 is equal to 0, which does not sound likely to me, x plus 1 might equal 0, or maybe x minus 4 is equal to 0. One of these has to be true. Okay, this is never true. This could be true when x was negative 1, and this could be true when x is 4. So I know that this is going to be a parabola that opens downward, and it's going to be pretty narrow because of the negative 2. So I'm just going to kind of draw what is, in my mind, a downward-facing narrow parabola. And it's got 2 x-intercepts, so I'm going to draw in an x-axis. I'm going to label those because that's kind of what we're doing here. This is x equals negative 1, and that's y, x equals 4. Okay, and that's as good of a sketch as we need. It's 12. Y equals x squared minus 8x minus 33. I don't see any greatest common factor here, so now I'm down to thinking I'm looking for 2 numbers that multiply to negative 33 while adding to negative 8. 33, that only sounds like 11 and 3 to me, and I see that I could probably make that happen. So since this is negative, I know that the bigger number needs to be negative because I'm going to add them together to get negative 8. So I need x minus 11 and x plus 3. Okay, for an x-intercept, I need y equals 0, which gives me 0 equals x minus 11 and x plus 3. Okay, applying the zero product property, if these things are multiplying together to equal 0, that means one of them has to be 0. So that means either x minus 11 is equal to 0, or maybe x plus 3 is equal to 0. Okay, I can add 11 to both sides, subtract 3 from both sides here, and get myself a couple of x coordinates. This is just going to be a regular upward-facing normal width parabola, but because we don't have any sort of grid here, we don't know what normal width is. It's got these two x-intercepts, so I know that the x-axis is going to run through and hit it twice. And this would be where x is -3, and that would be where x is 11. Right, number 13 is y equals 5x squared, 15x, and -50. Okay, I'm going to factor out a 5 from this one. X squared plus 3x minus 10, right? And if you factor out a greatest common factor, it's generally a good idea to just kind of check 5x squared, 15x, -50. Okay. All right, so that's equal to 5 times x plus 5 times x minus 2, right? Two numbers that multiply to -10 and add to +3. And again, if you need more practice on your factoring, let me know. I've got a bunch of factoring worksheets. I've got endless factoring worksheets from previous years, from really when I taught college algebra. So if I need the x-intercept, that'll be where y is equal to 0. And so 0 would be equal to 5 times x plus 5 times x minus 2. Okay, if these things are multiplying to 0, one of them has to be equal to 0. Either 5 is equal to 0, which is never true. X plus 5 could equal 0, and that would be where x was -5. Or maybe x minus 2 is equal to 0, and that would be where x is equal to 2. Okay. I've got two x-intercepts, two zeros. Sometimes we call these zeros because it's where y is 0. And sometimes they're called roots or solutions. There's a lot of names for this. Okay, I'm going to try to stick to x-intercepts, maybe zeros. I know zeros is a name that a lot of the kids in my calculus class would call this. Okay, and so, but it opens up, and it's going to be very narrow because of positive 5x squared. So I'm thinking it's about like that. It's got these two x-intercepts, and so I'll label them here. X equals -5, x equals 2. Let's see, and number 14, maybe I can squeeze that in as well. F of x equals 2x squared minus 20x. Okay, this has got a greatest common factor. I'm seeing that 2, both of those numbers are even, so I can factor out a 2. But I'm also seeing x in both of these things, so I'm going to grab a 2x. And I'll say, what do I have to multiply 2x by to get 2x squared? I have to multiply by x. And then I'd have to multiply 2x by minus something to get -20x. I don't need to multiply by any x's because I've already got the x here. So I guess that would be 10. Okay, for an x-intercept, we need y equaling 0. So that would be where 0 equals 2x multiplied by x minus 10. And then if these two things multiply together to equal 0, either 2x equals 0, and I could divide both sides of this equation by 2 to get x equals 0. Or maybe x minus 10 is equal to 0, and I could add 10 to both sides of this equation. Okay. And if I've got x-intercepts at x equals 0 and x equals 10, and I've got an upward-facing, somewhat narrow parabola, okay, I could say, all right, it's going to look like that. That's going to be my first x-intercept. That's x equals 0. Here's my second intercept. That's x equals 10. Since this is x equals 0, I know that's going to be at the origin, so I can maybe even draw that in as well, just because I can. That looks pretty good, right? That will be all for that one, though. That's a sketch. Oops. G of x equals -3x squared minus 3x plus 6. All right, this is a situation that I didn't put in the notes because I was really trying to stick to the easiest cases possible. And so I'm not going to put one of these with a negative leading coefficient that you need to factor on the quiz for this time. But this is something we're going to need to be able to deal with. So I figured might as well get you started now on the homework while you have, And it's pretty low stakes, right? So I see the 3 on all of these, and I see that it has a negative leading coefficient. My advice to you is going to just, if you see negative and you have to factor out the negative at the beginning. We'll factor the negative and the 3. So I'm going to say this is negative 3 times, because I don't have x in all of them, I can't factor out anything else. Okay, I would have to multiply negative 3 by x squared to get negative 3x squared. Okay, what would I multiply negative 3 by to get negative 3x? I think just 1x, positive 1x minus 3, yeah. And then I would have to multiply negative 3 by negative 2 to get positive 6. Okay, and then this is something that I can factor. What are two numbers that multiply to negative 2 while adding to positive 1? That would be positive 2 and negative 1. So I'm going to say that this is negative 3 times x plus 2 times x minus 1. Okay. And if I want the x-intercept, that's going to be where y is equal to 0. And, okay, y equals 0, that would be 0 equaling negative 3 times x plus 2 times x minus 1. Okay, and if these things are multiplying together to equal 0, that's because one of them is equaling 0. So I've got either negative 3 equals 0. It's not ever going to be true. X plus 2 equaling 0. That equation could be true if x was negative 2. Or x minus 1 equals 0. And that equation could be true if x was equal to 1. Okay. So now I've got two x-intercepts. I know that this one opens down, and it's somewhat narrow. Okay, so it opens down. It's got the two x-intercepts, so that would be right here. Okay. And what was I going to say? Oh yeah, this is negative 2 is less, so it's on the left. 1 is greater, so it's on the right. And there I've got myself sketched. Okay, good. Yeah, I was worried that we were going to have, like, all of them were going to have exactly two x-intercepts, and well, you can only have one sometimes, and this is going to be that situation. H of x equals x squared minus 10x plus 25. Okay, I'll tell you about perfect square trinomials and how to recognize them, but in general, my advice is just to approach this thing just like anything else. What's two numbers that multiply to 25 and added negative 10? Negative 5 and negative 5. So I've got x squared, pardon me, we don't do group and factor yet. We're going to say this is x minus 5 times x minus 5. And you could call that x minus 5 squared on the outside if you like. Okay, that's fine. I'm just going to leave it as x minus 5, x minus 5. If I want the x-intercepts, that's where y is equal to 0. So 0 would be equal to x minus 5 times x minus 5. And then I could say, okay, well, these two things are going to multiply to 0 anytime that x minus 5 is equal to 0, which would be giving me x minus 5, or anytime this x minus 5 equals 0, which would be the exact same time when x is equal to 5. So I just have one x-intercept. Okay, so that means that that's where x is 5 and y is 0. Okay, that's going to be my vertex. It's going to open up because it's just a regular y equals x squared kind of parabola. And so since it's the y-coordinate of the vertex is on 0, I mean, the vertex is the x-intercept, it's just going to look like that. It's just going to have one x-intercept. Maybe I'll just put a little 5 there, because we'll be interested in graphs like this also. Okay, and then and I'll also say that the reason why it just barely touches and then bounces off is because there's two of these, and that's this is something that we'll get into more in this class. Especially once we have more than two powers here, and we can have multiple factors, and sometimes some of them are repeated. We'll be really interested in that in this class. But that's the reason why it bounces, is because there's two of these factors that are identical. Okay, but that's all I've got to say about that for now. All right, number 17. The graph of y equals ax squared plus bx plus c. Okay, so we know it's a parabola. Okay, passes through the points 2, 3, 0, 10. Okay, that's a y-intercept, and 4, 10. Okay, find the coordinates of the vertex, the y-intercept, and the axis of symmetry. Okay, we're going to need to draw a picture, because obviously there's something that we're supposed to see here. All right, so we basically, I'm seeing everything being positive, so I'm just going to draw the first quadrant. Okay, we've got x equals 0, x equals 2, and x equals 4. So maybe I'll mark off 2 and 4. And then we've got 3 and 10. Okay, so 2, 3, 0, 10, 4, 10. Okay, I'm seeing, and I know it's a parabola because it's y equals ax squared plus bx plus c. So I know this is the graph, meaning that point down at the bottom, that's got to be the vertex. Because it's halfway in between these 2 points that have the same y value. That's how I know that for sure, right? There's not, these have symmetry to them. There's no like lopsided parabola that, I don't have a scrap of paper because I'm going to be out with a sub today, but I guess I'll just go over here and say, we don't have one where it's like this, where it's relatively narrow and then like super wide after. That's not a parabola. That's something else. Something we're not going to be talking about, at least in this semester. Maybe next semester I think of a situation where we run into something like that. Oh, wait, that's not the right side. Okay, yeah, so the vertex is 2, 3. Okay, the axis of symmetry, well, that would be this thing right here. It's the set of all points where x equals 2. And then the y-intercept is going to be y equals 10. So x equals 0 and y equals 10. Notice this one has no x-intercepts. That's interesting. We'll be talking about that more in the next few days. Then there was something else I was going to point out. Another way I could ask this question is if all of this happens, what's the value of negative b over 2a? Okay, that would be kind of a tricky question that you'd have to like kind of synthesize some information to put it all together and get that right. Number 18. If the vertex of a parabola is at 5, 2, and the parabola passes through the point 1, 0, okay, what are the x-intercepts of the parabola? Well, I see one of them right here, x equals 1. Okay, so I think I should probably be able to use a symmetry on the vertex and having one x-intercept to reflect across the axis and find the other. But again, the vertex is at 5, 2, so that's over where x and y are both positive. X is 5 and y is 2. Okay, I've got the x-intercept 1, 0. Okay, so I know if this is the vertex that the axis of symmetry runs down through it. X equals 5. So if I've got this point, I know I've got this point over here across the axis. That's a little sharp, but what can you do? Okay, so if I go to the right by 4 to get from 1 to 5, I could go to the right by 4 again to get from 5 to this number, and that would be 5 plus 4 is 9. So the x-intercepts are, well, x equals 1 and y equals 0, and x equals 9 and y equals 0. Okay, that's all the problems for this homework. Thanks for watching. I hope it helped.